Alright guys, we're going to be solving on a question from the second chapter of the Meriam textbook, Engineering Mechanics, and in this one we need to determine the resultant R of the two forces shown, firstly applying the parallelogram rule for vector addition, and in the second method we should sum scalar components. So we have these two forces in here as we can see. Let's start with the A part where we use the parallelogram rule. So let's make a parallelogram first. So this will be a resultant R, and we have some information about the angles if you look at this question. So this angle here would be 30 degrees since we have 90 minus 60 or 30, which means this angle here is 30 degrees. And if we do one line parallel to X, this will be 30 degrees as well, and this will be 90, so that angle would be 120. So what we have in here is 120 degrees, and also the force 400 can go in here too. So it's the same force. And if we do our law of cosines for the triangle that I'm highlighting in yellow, so our r squared would be equal to 400 squared minus plus 600 squared minus 2 times 400 times 600 cosine of the angle between the two forces, 400 and 600, which is the 120 that we found. So 120 degrees here. So basically our r would be the square root of what we have on top. So let's calculate that. Square root of 400 squared plus 600 squared minus 2 times 400 times 600 times cosine of 120, and that's going to give us 871.78 newtons. So now if we want to find the angle that it makes with our horizontal y-axis, we can call this angle here alpha, which is what we have in here. It's the same, and if we this time use the law of sines, we're going to have sine of alpha over the side in front of that would be the 600 Newton force sine of 120 over our r, which was 871.78. So alpha would be sine inverse of 600 sine of 120 over 871.78. Let's calculate this. So sine inverse of 600 times sine of 120 divided by 871.78. Oh, we made a mistake here. So that's going to be 36.59 degrees. So if we want to report our R, would be 871.78 Newton, and the angles that it makes. So we found the angle between R and the y-axis, which is alpha. So if we want to find that angle with x-axis, so this would be our alpha, we simply have 90 minus 36, so we're just gonna which is gonna be 53.4 degrees, and that angle would be the angle of the r with x-axis. So that was the A part of the question. And if you want to go with the scalar component, it's pretty simple. We have our resultant in vector form, which would be rxi, which is the unit vector for x, and ryj, and j is the unit vector for y. So rx would be sum of all forces in x direction. If you look at these two forces, our 400 force is vertical, so no x component, and the x component of 600 would be this component in here, which will be 600 cosine of 30. So 600 cosine of 30 degrees. And that's pretty much it. And it will be positive since it's to the right. So 600 cosine of 30. That's going to be 519.62. And ry, we're going to do the same thing, sum of all forces in y direction. we have minus 400 downward, and we also have the x component of the 600, which would be this component here. Now will be negative since it's downward, so minus 600 this time sine of 30. So sine of 30 is 0.5, so it's going to be 400 plus 300, which is 700, so negative 700 newtons. So that's going to be our resultant vector 700J. The unit would be in newtons. And we also can find the resultant, which would be the square root of rx squared plus ry squared. So the square root of 519.62 squared plus 700 squared, that's going to give us 871.78 newtons. We can double check this with what we found in the previous method, which is exactly the same. And also, if we want to find the angle with x-axis, so we found 700 for y and 519.62 degrees. That's our r. And if you want to find this angle here, what we're going to get, if we call this one beta, beta would be the tangent inverse of the opposite 700 over the adjacent 519.62. And let's see if we get that 53 that we got in the previous step or no. Tangent inverse of 700 divided by 519.62. And our beta would be 53.4 degrees, which is exactly what we found in the previous part. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.